Hey everybody, welcome back. In this video we're going to be looking at identifying the parts of a polynomial function using appropriate vocabulary. And from where we sit right now, that's extra challenging because you don't even know what a polynomial is. So let's start there. In order to really understand what a polynomial is, we're going to start in a weird place. Have you ever seen one of these? This is all the rage in elementary schools, and especially if you have children, these things are lifesavers. But what this is kind of a shelf, I guess you would call it. There's nothing else really to call it. But this piece right here is just a large container with these squares in it. And they sell these fabric boxes. So these are collapsible and kind of flexible. And these boxes are designed to fit exactly in those squares that you see. So you can fill up these boxes with whatever you want and shove them there on that shelf, and voila, you look like you're organized, even if you've just thrown lots of junk into those. Not that that's what happens at my house. I don't know where that came from. Anyway, the idea is we have one large container that has many smaller containers in it. We're going to stretch this a little bit and take it where we have not one large container with many small containers, but one large idea with lots of smaller ideas inside of it. So to give you an example of what I'm talking about with something that you're completely familiar with, let's talk about dogs. There are different types of dogs: German Shepherds, Bulldogs, Golden Retrievers, Poodles, but all of them are dogs. And so we have this larger container, this larger idea of dogs, and we can have these smaller separate compartments of different types of dogs, and each one can go in its place on the shelf. So what this means is we can take this one category, dogs, and further divide it into smaller and smaller categories. And if you understand that idea, the idea of one big container idea and then smaller, more specific ideas within it, like these boxes, you're ready to understand a polynomial. So a polynomial is just a class of functions. It's a group of functions. It's this whole big collection. Just like dogs contains all that breeds, polynomials contain all these different types of polynomials. And we've studied one already. We've studied a type of polynomial called a linear polynomial. And so everything we've learned about linear functions fits in that box. And that box is just part of the story of polynomials. And what we'll find is there are other categories as well, and we'll learn to figure out what category a polynomial falls in. But just so that you can see some of those names coming up, we could talk about quadratic polynomials, cubic polynomials, quartic polynomials, etc. But all of them, when we lump them together, are called polynomials. So that's the idea behind what a polynomial is. Let's get a little more specific. If we're talking polynomial, we're talking about a mathematical expression that contains addition, multiplication, and exponentiation. So it's not going to have anything else other than those three. Subtraction and division, of course, are just considered subsets of addition and multiplication. So I guess you could say addition, subtraction, multiplication, division, and exponents. But it also has to meet the following requirements. Your exponents have to be numbers. They can't be variables. So if you see a variable in an exponent, that thing is not a polynomial. All the exponents have to be positive. And if you are really good with your exponent rules, you know that also means that you can't divide by a variable. So we have to have numbers as exponents, they have to be positive, and they have to be integers. They have to be those whole numbers. So all our exponents have to be positive integers on these polynomials. And if it meets that really ridiculously broad definition, it's polynomial. And there are tons of them. So let's look at some examples and some non-examples. So let's start up here with 2x squared plus 5. We look at this, it contains multiplication, it contains exponents, and it contains addition, but no other weird thing we haven't seen, so it fits that definition of a polynomial. If we look at the exponent here, which remember is the 2, it is not going to be a variable, it's a number. it's a positive number, and we can see that it is a whole number. So that fits all our definitions of a polynomial. And that's all you have to ask. It doesn't matter anything else about how it looks. Doesn't meet those rules. So we look at this one. Addition, subtraction, multiplication, and we have exponents. So that part's good. All the exponents are numbers. They're all positive numbers, and they're all whole numbers. So, cha-ching, that's a polynomial. And again, these are the only rules you're considering. There are no other rules to look at. So here, I've got just subtraction. I don't have any other operations, but that's okay. I'm allowed to have just subtraction. I don't have any exponents, but that's okay. All the exponents meet the rules. So this is a polynomial as well. And I want to add one weird example in here that I didn't originally add, but I want you to check out. What if we just had the number 4? It doesn't contain any of those operations. That's okay. It doesn't have an exponent, but the exponent meets all the rules. Guess what, friends? This is a polynomial, as weird as that sounds, because it does fit all those definitions. There's nothing that we said there that isn't true about that. So now looking at the non-examples, why don't these things fit? If we look at this one, it's got the addition, the subtraction, exponents. We do see some division here, which would be fine if that was dividing by a number. However, we're dividing by a variable. That is a no-no, and so this thing is not a polynomial because we're dividing by that variable. If we look at this one, everything looks normal until we see this exponent right here, which is negative. Negative exponent, not a polynomial. Everything looks good as far as form because we can kind of see that this is what a polynomial is going to look like. But in this case, we have over here decimals as exponents, got to be whole numbers, not a polynomial. So now let's look at some specific terms. We're going to look at a polynomial. So this meets all our definitions of a polynomial. And we're going to look at specific pieces of that and use proper vocabulary to describe those. Because if we don't have that proper vocabulary, when we study specific types of polynomials later, it'll be a little bit harder to distinguish what we're talking about. So the first thing you got to know is what a term is. So in this case, and this mark here is even a little misleading, the term would be negative 9x squared. Notice that it includes the negative sign in front of it. And what a term is it's a section of a polynomial containing only multiplication and exponents, so no addition or subtraction, and it's separated from the other terms by addition or subtraction. So let's look at how many different terms we have here. In this polynomial, we've got this 5x to the 4th. Notice that that contains multiplication, exponents, but no addition or subtraction. Then we have this term right here, and I've included that plus sign, but I only want you thinking of that plus sign as being the sign of that coefficient. So that just means a positive 3. So positive 3 times x raised to the 3rd power, just multiplication and exponents, that's a term. And again, notice this plus sign separates this term from this term. So each one of those plus or minus signs acts as a separation point for all my different terms. And you can see in this polynomial that I have 5 different terms. Now the reason this will be useful to us later is maybe we want to talk about what's going on in the 3rd term or the 5th term or the 1st term, and so this helps us pinpoint exactly what part of the polynomial we're talking about. Another thing that we can talk about is coefficients. These are the numbers written in front of the variables, and when you're talking about your coefficients, I always want you to include the sign in front of it to tell you whether that coefficient is positive or negative. So in this case, the coefficient is positive 3. For this term, the coefficient is positive 5. Here, the coefficient is negative 9 for this term. And notice, each term has that. So the coefficient is just the number written in front of and multiplied by the variable. Remember, when they're written together, that just means multiplication. And it takes the sign in front of it. So make sure that you're always taking that sign if we're talking about the coefficient of, say, the second term or the third term or wherever we're looking. Another place we can look is what's called the degree of a function. Now, because we've only got one variable in this, and most of the ones we'll be dealing with will only have one variable, the degree is going to be equal to the exponent. But actually the degree is the sum of all the exponents on the variables in an individual term of a polynomial. So we can talk about the degree of individual terms, like I can ask you what the degree of the third term or second term or whatever is, or later on we'll talk about the degree of an entire polynomial, but it's conversation for later. We'll get there. Looking at this, I can look at specific terms. So in this one right here, the second term, the degree of that term would be 3. If you add up all the exponents on the variables, well, we've only got one variable, it's going to be 3. If we look at our first term, the degree of this term is 4. It's whatever the exponent is. Now, this is pretty simple when you have exponents. When we get down here, it's a little confusing. There is no exponent, but there is a variable. So here we would say the degree is 1. If you have no exponent and no variable, we say that the degree is 0. And you'll get more on that later. Now that we have all that under our belt, we can talk about some things that will become important later. I just want you to know the words and have heard them. We can talk about the leading coefficient and the leading term, and this is exactly what it sounds like. If it's leading, it's up front. So the leading term is the term that is at the very front of the polynomial. And we'll learn that there's a specific way we're supposed to write these called standard form that makes our leading term kind of important. But for now, you know that it's in the front. And so the leading coefficient, no mystery here, is the coefficient of that leading term. So if you see those words, that's all that means. Don't get too upset about it. And then we have a very special term that is going to get its own name right now, called the constant term. And so the constant term is the term that has no variable. It's just a number by itself, -7 in this case. And that is a special term because if you're looking at the graph of a polynomial, which we won't do much with, but to tie this to other things that you know, that number is going to be the y-intercept of the function. And we say that the constant term has degree 0. Again, it has no variable and no exponent. So that makes it kind of special and worth talking about. All right, I've thrown a ton of vocab at you. So there is all of this. If you look back through it, it's tons of vocab. You must learn this. If you don't have a way to talk about these, it is going to be very difficult to be successful with talking about these polynomial functions. It's like trying to talk about different breeds of dogs when you don't know the name. You're resorting to describing them, and it's just difficult and painful, and nobody knows what you're talking about. So learn all of these. Make a foldable, make some kind of study guide out of this, flashcards, something. Devote some thought into learning what these words mean, and those will be incredibly useful to you as we go and study them in the future. Best of luck, my friends.